Welcome back, everyone. Hope you enjoyed lunch. I would now like to welcome our next team, titled Integrating Intelligence, Building Shared Conceptual Grounding for Interacting with Generative AI. They're presenting their work on building a conceptual grounding for effective interaction with AI tools. Let's give them a warm welcome.
All right, thank you. So I want to start off with a question. Who made this photograph? And while you take a moment to ponder this, admire its choices of tone and contrast. The photograph covers the full range from deep, dark black shadows through a gradient of gray in the sky, a lighter gray moon, and then full bright white in the lit, snowy areas. It's a majestic and I think rightly famous photograph. So who made this? GPT. Okay, so I heard from James Ansel Adams, and indeed, Ansel Adams, yes and no. So Ansel Adams is credited as the photographer. He shot this picture, but this special edition was printed on paper by his assistant, Alan Ross, who's pictured here. And Ross has said, although Ansel's hands were not in direct contact with the printing, his vision always was. The challenge was to be able to anticipate and respond technically to his requests. Make it a little darker over here. Can you make it a bit more contrasty, he would ask. In his 6 years as an assistant, Ross learned what Adams meant by concepts like contrasty. He learned to interpret what Adams wanted. And so this photograph is indeed credited to Ansel Adams alone because Adams is the person that had the vision and made all the critical choices about its overall look. Ross assisted Adams in executing those choices. Okay, here's another Ansel Adams photograph printed by Alan Ross. And again, look at the control over the tones. Here, unlike the last image, the sky and the tree leaves use a limited set of light grays and whites, and black is fully reserved for the trunk, making it really stand out. So I imagine a conversation between Adams and Ross as they made this. Adams asks, can you make it a bit more contrasty? Ross responds, by contrasty, do you mean I should use the full tonal range? Ross is checking that both of them understand the concept contrasty in the same way. He's trying to ground the concept. Adams says, no, let's use a limited set of tonal zones, 6 through 9 for the leaves and sky, and zone 0 for the trunk. Adams is invoking his well-known zone system of tonal zones, assuming both of them understand what the numbers mean. And this zone system is very well known indeed. This is a visualization of the zone system from Wikipedia. So many people do know about this. And what Adams is doing in the conversation here is using conversational repair to communicate exactly what he means by contrasty so that Ross can print the photograph to match Adams' vision. And so here what's happening is that their prior experience working together and the conversation allow them to establish a shared set of concepts that facilitate the creation of the image Adams wanted to make. Authoring content that you care about in any domain requires having opinions and making choices. Working with an assistant requires communicating those choices precisely to the assistant. Okay, so what does this have to do with AI? Well, the promise of generative AI tools is that they can serve as a kind of collaborative assistant in creating content. An assistant, like Ross was to Adams, that will help authors quickly generate high-quality content and results. Maybe in as little as 20 seconds, as suggested in this AI-generated cover image. So let's work with generative AI to make an image. And here, I want to make an image of Stanford's main quad and Memorial Church, framed through the arches, looking something like this. This is a real photograph. But I want to render this after a heavy snowstorm. And AI, of course, is good for imagining something like this because snowstorms rarely happen here at Stanford, and so I want to use AI to make it. More specifically, I want to see if I can work with AI to make tonal choices similar to the ones Adams used in this oak tree image. In this case, with the sky and the church facade in white and light gray, and the arched entryways in full black. Now, I just want to take a moment to recognize that this is just an example of something that I want to make, and I realize that not everyone might be interested in creating this kind of an image. But the process I'm about to show you applies in many situations, anywhere really, where you're trying to author something you really care about using AI as an assistant. So I start by giving ChatGPT 5 this prompt. And here's the result. And in some ways, this is absolutely stunning. From a text prompt alone, I get a picture of Memorial Church with significant snow in the quad. The AI seems to understand the concepts of black and white, of Memorial Church framed in the arches, and snowstorm. But one concept that I really care about is contrast. And here, the facade is really dark gray, the mosaic detail is very, very muddy, the foreground arch has very little contrast. It doesn't at all look like that white and gray oak tree image. So I ask for more contrast, and a few iterations later, I get this. Unfortunately, ChatGPT gives me a nighttime image that isn't at all what I want. So I try various wordings that might bring it back to daytime. A few iterations later, iteration 7, somehow ChatGPT forgets that I want a black and white image. It adds a bit of blue color in the sky, but at least it's daytime, and I get some contrast in the foreground arch, which I like. So at this point, I start to adjust the tones for the white on gray look of the oak tree, first using Adams' zone system with various wordings. This is iteration 9. Unfortunately, it's another nighttime image. It seems like ChatGPT may not know about the zone system, but I stick to it for a few more iterations. This is iteration 12, and we're back to daytime, but the tones in the sky and the facade are still wrong. At this point, it's fairly clear to me that ChatGPT doesn't know Ansel Adams' zone system. So here I switch strategies. I try to directly specify the gray tones that I want in various regions. And I try lots and lots of different wordings, many, many iterations. I end on iteration 27 with this. I basically give up. The image still isn't what I wanted. The facade is too dark. The sky and rooftop snow kind of blend together. You can't see a crisp definition of the snow. And it's partway there, but it's not really what I wanted to make. What's worse is that I don't know how to adjust the prompt to communicate to ChatGPT how I want the image to look. I can't communicate my design choices. I wouldn't be comfortable with this result as representative of my work. And so to me, the end result is AI slop. And moreover, getting here took several hours of essentially trial and error prompting to even get to this point. So the question is why? Why do we end up with this type of slop in human-AI collaboration in comparison to human-human collaboration? And our team believes that there's one key difference. In human-human collaboration, we can establish shared conceptual grounding, as we saw with Adams and Ross, allowing the author to precisely communicate design choices to his assistant. In contrast, with human-AI collaboration, there's often a lack of shared conceptual grounding, leading to lots of trial and error prompting and end results that don't match the author's vision. An end result that is slop. So while the promise of generative AI is that it will serve as a collaborative assistant, the reality is that while they at first seem very amazing, they are terrible collaborators because we do not share conceptual grounding with them. And we've seen this is true for image generation. We saw this in the example of Memorial Church. Even though this magazine cover claims it took 20 seconds to generate, Karen Cheng, the artist who made the cover, has explained that it took her many, many hours of prompting to find the one for this image. She had trouble precisely communicating what she wanted because she didn't know how to tell it, the AI, what she meant. She lacked a shared set of concepts with the AI. And we've probably all experienced similar problems in working with AI because it occurs in every domain. It shows up when using AI to write text. Here, I have to ask for multiple rewrites of a one-sentence bio, never getting something that I like. It shows up when using AI to make diagrams. Here I wanted a labeled diagram of a bike, and no matter how I prompt it, it mislabels the parts. It includes labels I don't want. It shows up when using AI to generate 3D objects. Here I asked for a suburban single-family home. It gives me a modern-looking duplex. It shows up when using AI to make video, to make music, to make animations, really to make anything. So what we've seen so far is that authoring content in any domain is about being opinionated and making design choices. Working with an assistant requires communicating those choices precisely to the assistant by building a shared set of concepts. And lack of shared conceptual grounding leads to slop. In fact, recent articles in the Harvard Business Review and the New York Times have recognized the problem of AI-generated content. Too often, the content seems like it's well suited for a task at first, but is problematic on closer inspection. And these articles explain how such AI slop is starting to lead to disillusionment about the place and value of generative AI tools. So that brings us to the overall goal of our project. We, in this project, will develop content creation tools that achieve shared conceptual grounding between AI assistants and the humans that use them. And our first objective is to understand the concepts that humans use when performing creative tasks, as well as the mechanisms humans use to establish common ground when they are working together with other humans. And since this objective is primarily about humans, our team has Judy Fan and Toby Gerstenberg from cognitive psychology, as well as Hari Subramaniam and myself from HCI to help answer this question. Our second objective is about making AI tools better collaborators by teaching them the concepts humans use when making content. This part of the project involves developing new AI systems and techniques, and so we have Xiaojun Wu, Kayvon Fatalian, Nick Haber, and myself who bring expertise to this side of the project. And since we ultimately need to understand how effective our AI systems are to real users, we have Nick and Hari from education who have expertise in validating AI models in the classroom. So in the remainder of this talk, Judy will first present the progress we've made so far on objectives 1 and 2, and then Kayvon will finish by talking about the impacts of our work as well as our goals moving forward. So, Judy.
Okay, thank you, Manish. I'm excited to be here to share with you what we've been up to, starting with objective 1. The key insight here was, just as Manish was saying, if we want to build AI systems that understand what humans think and how they think about what they want to create, we should start by learning as much as we can from the way that humans establish common conceptual ground with each other. But because no one can directly observe the thoughts in someone else's head, we have to rely on something we can observe, what people say and do. In other words, their behavior. So one of the top priorities for our team this past year has been to develop and refine experimental protocols for recording and analyzing how people communicate when creating content together. In our setup, we paired people up and gave them a design assignment. You could imagine giving them a version of Manish's Memorial Church problem. Except this time, they're trying to create a CAD drawing that captures its main structural features. People play either the role of the designer or the maker, assistant in our setup. And it's the job of the designer to come up with instructions that will help the maker create that CAD drawing. So what do they say? See, in principle, they could just ask for the end product, draw a memorial church, and skip right to the end. Or they could spell out what they want in excruciating detail. Draw an 84 by 30 rectangle, draw now a 30 by 15 triangle, and so on. Or they could start off by breaking things down into terms they think their collaborator will understand that are neither too abstract nor too specific. Like, let's start with the facade. There's a gable above a broad wall, a narrow frieze band beneath it, and go from there. We gave the designer a whiteboard too, so they had an easier time laying out what should go where. We then tracked how the maker interpreted these multimodal instructions by seeing what they created. Something important to point out here is that during this back and forth, that what is meant by a blob or a cross the designer draws on this initial CAD is not obvious when you look at these symbols in isolation. Instead, the interaction context is crucial for helping you infer that the skinny blobs must be the tall windows the designer is referring to. The round blobs are the entryways. That the T shape on top means that a cross should be added, but the X, which looks almost identical, means that whatever part of the CAD design it's on top of should be removed, but no more. And depending on how things went that round, they'd continue to refine their design. Say by asking with these red curves for the entryways to become arched. Interpreting what all of these curves, blobs, and crosses mean is deeply non-trivial, but it's something that we saw people doing readily and successfully in our setup. I'm just going to highlight one of the most recent studies that our team has run in this vein, where we used this method to capture this kind of naturally iterative, multimodal communication between humans in controlled settings at scale. In this project, which we affectionately called Mr. CAD, we gave people a huge variety of target CADs to communicate about. And when we saw people use the whiteboard on the first round to make sketches to communicate the overall appearance of these targets, they almost always kept refining the design by circling parts of the drawing, using arrows to say where things should move to or how much they should be rescaled. This was a major undertaking to collect over 15,000 rounds of communication, about 3,000 CAD designs with more than 2,000 human participants, providing broad coverage over some of the most common CAD motifs used in design settings, as well as a wide variety of ways that different people communicate about them, which is important because not everyone talks or draws the same way, but they still expect to be understood. One of the key insights from our analyses was that people expect to be able to give a high-level overview before further refining their design. And people are often able to figure out what a specific word or a drawn mark means in context on the fly and expect others to do the same. We've also had incredible momentum on Objective 2. And on this front, we've been inspired by the way that artists, really experienced creators, think about the work they do, which has helped us make progress in teaching AI systems about the key concepts these artists use. For example, the artist Betty Edwards, in her classic book, Drawing on the Right Side of the Brain, explained how artists often started drawing by first sketching its spatial composition. But in 2023, text-to-image AI generators force users to specify layout using natural language alone, which is imprecise about spatial composition. So here, the layout of the windows is easy to draw, but hard to specify in text. And this AI-generated image doesn't match the composition I wanted. And even minor adjustments to the prompt produces a completely new image, making iteration difficult. This is slop. So members of our team developed ControlNet, a technique for teaching text-to-image diffusion models about spatial composition. The input to ControlNet is a conditioning signal specifying the desired spatial layout. Here, a sketch or a human stick figure pose. ControlNet produces images that match the spatial layout information provided by that control signal. Adjusting the text prompt allows you to further control the output. You can ask for the building to be on a city street or inside a 19th century church. Or you can make sure that the image shows a chef in the kitchen. Inspired by ControlNet, in this last year, our team has developed AI image generation tools based on other concepts commonly used by artists. For example, artists usually create drawings in a coarse-to-fine manner, first blocking out the spatial composition by roughly drawing shapes and contours, and then adding in detail strokes to further refine their drawing. And we've seen that ControlNet allows sketch-to-image generation, but it doesn't support the coarse-to-fine workflow artists actually use. The problem is that ControlNet generates images that tightly match the conditioning sketch. So here the round regions for the head and body of the bird and cat look misshapen and distorted. To overcome that challenge, our team developed block and detail to give creators a way to convey to the system when what they just drew is meant to be a rough guide and when they want their sketch to more tightly control image generation. The way it works is that you can use these green blocking strokes to roughly specify shape, but when you want to, you can still use these black detail strokes to provide tight control. Here, the head of the rose is roughly blocked in green, but the stem, leaves, and sepals are placed precisely in black. And here's what it might look like if I tried to create a watercolor picture of a robin using this tool. Here, I'm using blocking strokes to roughly indicate where the head and body of the robin should go. Then I click Generate and wait for the first round of results. From these 4 options, I decide to go with this sample, which critically contains a robin in the correct location with a natural-looking shape. But notice now that if I tried to generate this image as if we were applying tight control by using the detail strokes, it looks way more distorted, which is not what I wanted. A little further on, I decide I really like this robin, so I'm going to use detail strokes to specify exactly where I want the beak, where the eye should go, and how I want the belly to look. But I realize I also want to add a branch for this bird to be perched on, but I only have a rough idea of where I want it to be, so I switch back to blocking strokes to give the system just rough guidance as to its position. And in our next iteration, I'm pleased to see that all of the results have the branch in the right position and orientation. As part of Objective 2, we've also developed tools for generating 3D scenes using a neurosymbolic approach. So given a text prompt, we use a generative model to produce a program in our scene language, which is executed, then rendered to produce a 3D scene. A human user is always in the loop here. They can inspect the output and the code to check for problems, then choose to either edit the code directly to fix them or send edit requests back to the AI for iterative editing. The AI can then update the program and execute it to update the scene. In the work I've shown you so far, the approach has been to take a concept we already know is useful and then start a project that teaches the AI system that concept. But what if a creator wants to collaborate with an AI system, and the AI has not yet been taught the concepts the creator wants to use? Well, we could use a bigger model and hope for the best, but that's expensive, and the model still might not have a shared understanding of the really important concepts. Or we could try to meet the AI where it is and prompt engineer and incur all of the frustrations Manish expressed in his opening example. Or we could teach the AI by giving it examples of what the creator means. The problem is that typically a large number of examples is needed to teach any concept, so this is prohibitive for establishing common ground once collaboration is underway. For this reason, we've been exploring techniques for rapidly teaching LLMs new concepts using only a very small number of carefully chosen examples, and the results so far have been quite promising. With that, I'm turning the floor over to Kayvon to tell you what's coming next.
Thanks, Judy. All right, so Judy just told you about a few examples of work that we've done in year one. And before I talk about what's next, I actually would like to take a moment to talk about some of the impacts that that work has had in year one, because we've been very pleased with the impact that they've had both academically, industrially, and in some of the communities that we're hoping to serve. So to get started, let's just start with academics. You know, the work that in addition to the work that you've already heard about, we've done a lot of projects. And those projects have been submitted and published to nice venues in graphics, AI, psychology, and education. And we've worked hard to disseminate the ideas and the philosophy of this approach to many different communities. So for example, we have led academic workshops like this one at SIGGRAPH, which brought together cross-disciplinary teams of technologists, psychologists, and creatives. And you can see here, Manish and Judy were key speakers at that event. We've also incorporated our thinking into the classroom. So we've edited 2 different CS classes. I'm showing you a syllabus of my own class, where we have a number of lectures that focus on topics like neurosymbolic thinking or human-driven controls of AI. And Judy's teaching an entire class this winter on the topic of modeling cognitive processes during creative work. So you can think about it in short as we're trying to develop technology, sure, but we're trying to educate, a legion of Stanford students in a manner of embodying this philosophy and the ideas of human-centric control at the very start of everything. Now, one of the things that our team prioritizes is open source. And we do that because we believe that if you can get software out into a community, you can really quickly get feedback that far outweighs anything you might get from peer review. So ControlNet, one of the projects that you just heard about, was released a few years ago. It has 30,000 GitHub stars. FramePack, a video generative model that was released just a couple months ago, already has 15,000 stars. And these pieces of software are inspiring creatives to experiment, generate new types of media on their own laptops, outside of the services from the various communities. And because of this open source, communities are starting to pop up. So these releases have led to open source communities not created or seeded by us, of people using these tools. And they like to share what they create on Reddit. For example, here's a ControlNet subreddit and a FramePack subreddit. Or they share on X or Twitter things that they've created and how they've created it. And here are just some examples from all around the world. Since this is open source, they also contribute to the software. So there's examples of people saying, hey, I created an AI to produce the inputs to feed into your AI because this is the workflow that I needed to do my project. We've also, in year one, the projects that you saw earlier are beginning to have impacts on industry. So, for example, at Roblox, which, if you don't know, is the world's by far largest gaming platform, there's a broad goal to allow players to type in a prompt and describe an object to create. So, for example, maybe I type in something like, a tall monster truck made out of futuristic starship parts. And then have the AI generate a functional version of the object. So if you give a second for me to wait for the AI to complete, you can see that now there's a car that you can get in and drive around in this experience. Now, Roblox initially thought that their goal was to produce an intelligent AI that produced behavior. Right? But the game creators, like the game that you see here, they have a very precise notion of what objects in their game can do and what they shouldn't do. For example, in this game, the whole point, the fun, is to have an interesting suspension on the car so you can go sliding around and generating effects and skid marks and stuff like that. But you're not supposed to have a weapon on this car because this is not a game about shooting. So some of the ideas that you saw earlier, this idea of teaching an LLM rapidly using many examples, we're working with Roblox to use that technology so that when people create a game, when players create something, it is consistent with the concepts that that game developer wants to have in the game. Okay. So, oops. Manish, why am I playing again? Okay, got it. All right, so to summarize, we were actually a little surprised by some of the impact we had in year one. And so now I'd like to say a few words about our process and where we're going next. So first of all, we have a big team. You've met, or you've at least been introduced to some of the PIs, and this team has met regularly. And what I mean is the PIs have been meeting weekly in some fairly rigorous meetings that I would say are challenging. And if you've done any real cross-disciplinary work, you know that you've really got to kind of hash out some ideas in order to get something better. And so those meetings have been very productive and very revealing. We've also met a second time a week with this much larger group of students for them to share ideas, see each other's projects, and effectively start building our own form of common ground. This team of large people, as I said earlier, has produced a lot of work. But on this slide, what I'm highlighting in red are the projects that involve multiple PIs and are starting to get a little bit cross-disciplinary. But I think we'd be the first to admit that for pragmatic reasons in year one of the grant, most of the projects are either projects that I would say are Objective 1 projects, where we're studying how humans think, or Objective 2 projects, which are about building ideas that we kind of already knew about into AI systems. And so the obvious next step is we need to join these efforts. We need to take things all the way through in order to produce some really interesting new tools. And as we do that, one of the big goals is to take some of the studies that we've been doing that are largely been on smaller populations, on convenient subjects, and take them out into the field and ask people questions and study how they behave when they're using our end-to-end tools. And luckily in year one, we've been establishing good relationships with communities, whether it be open source communities, industrial partners, academic partners. So we know where to find the folks that we really want to understand how they're using those tools. Okay, so I want to wrap up, and I want to take a big step back here and think about where we stand a little bit, both as a team, but as a community. Our work is built around the idea that authoring quality content in any domain is about being opinionated, and it's about making choices at many levels of abstraction. And that's true if you're Ansel Adams. It's true if you're an NFL football player trying to figure out what clothes you're going to wear when you walk into the stadium because you're trying to build a brand. And it's true if you're a kid playing with your blocks on the living room floor because you care a lot about what you want that day, right? So if we're going to augment creators like this, well, we need assistants that understand precisely the nuances of what these creators want to create. Unfortunately, this nuance, which we believe is so important, is getting lost in the conversation. So we have technology companies that are claiming that large-scale, internet-scale imitation is equivalent or a replacement for humans actually making choices. And on the other hand, we have other groups that see technology only as a source of AI slop that is designed to crowd them out of their workplace. But we're seeing that when you develop AI technologies that can establish common ground with human creators and help creators be more productive in using the concepts that they care about and are appropriate for their task in hand, these technologies can be and are often embraced and are very useful. So we believe heavily in this. And one thing in addition to developing technology that we've put some real effort in year one is on outreach to leaders to communicate this view. So I want to end with one example. So at places like Roblox, the communication not so long ago used to be that AI was going to make it possible for just everybody to make games. Right? That was the communication. And over the past year, members of our team have been in very close face-to-face contact with folks at Roblox, having conversations about the role of the human in the creative process. So what I'm going to play for you is a clip of the VP of AI at Roblox. This is just a month ago of him standing on stage at RDC. And let's just listen to what he says about how he's now talking about AI.
Is creator control is the most important thing for us in AI. We want to build everything such that you as the creator can control the style, you can control the size, and you can control the behavior so that the AI-generated objects are still objects that you would want in your experience.
Okay, so this is a message about human choices being the essential driver. And statements like this coming from a big company like Roblox supporting such a large creative community are pretty encouraging. And we expect that our work will provide the technical foundation for statements like this to actually be realized and benefit society. So I'm going to stop here. I think you just got the message. Thank you to everybody that was listening, and I guess I turn it back over to whomever I turn it back over to, right? Okay.
Thank you so much, Manish and team. We'll now invite the team back to the front. You can take a seat for the Q&A portion. And we're going to open up questions to the selection committee first, and then if there's time remaining, we'll go to our in-person audience.
Oh, there we go. I was going to start before you sat down because I didn't want to run out of time. Nice seeing you again, Manish. So yeah, fabulous work. I'm really a big fan of human and AI grounding work. And I have a two-part question, or two pieces of the question. Number one, methodologically, is there a sense that studying design and grounding around creatives and design processes in 2 and 3D spatial space of sorts can generalize to other grounding challenges with cognition between machine and human, in terms of what you're actually, the methodology you're applying here, applying methodologically to other areas of cognition where you're looking for grounding. And secondly, do principles that you've learned directly through the study of the design process apply directly to other grounding challenges, which is a broad area, Herb Clark, on and on and on. So curious about both pieces of that question.
Oh, can I start and then pass it off? Yeah, thanks so much for the question. I think we believe in the full round-trip journey, starting with humans and human cognition and taking human intelligence and creativity seriously. How we've managed to coordinate our ideas and imagination to create communities like we have here at Stanford and beyond, and learn as much as we can, which is the strategy we've taken, to think about and imagine paradigms for human AI creative collaboration that's rooted in that tradition, that longer history. But then, of course, with new AI systems that can collaborate more flexibly and generally with human creatives, we really hope that feeds back and really pushes the frontier of our knowledge of human intelligence. What are the ingredients that really gave rise to uniquely human creativity and intelligence, which I think are really, really deep questions that I really hope in the course of our work we come back to. And anybody else wants to jump in?
Maybe as the psychologist in the team, I'll add to that. So I'm very much thrilled to be part of this team where really the human is in the center, right? And that is, psychology for us. And I think Kayvon said towards the end, there's this one bet that you will take the reflection of the human output and think that that's enough, right? The internet, the big artifact that we kind of collectively produced. But we don't think that that's enough, right? We, as psychologists, we run experiments to try to understand how the human mind works. And Judy had wonderful examples of how so much of cognition works in the moment, right? And it's extremely contextual, it's extremely driven by the grounding in this specific situation, and we don't think that the internet emulates that sufficiently. So I think the techniques that we've developed in psychology, whether those are the way in which people are conceptually communicating, or how we can really understand what something means by building computational models and testing that experimentally, is key to building this conceptual grounding.
Maybe if I could just say one more thing about generalization to other domains. So, right, one, speaking as somebody who's representing education here, we have been thinking a lot about how this sort of framework can help build or enable people to create education content, right? Both making things for students, making things that teachers can use to make things for students. And I think at least in some early work, and this is I think where we're at this stage. I mean, well, Harry can maybe speak to more some work that's a little further along, but I think this is definitely where it's as we go towards year 2 and 3, we'd like to really start to see synergy between these Objective 1 and Objective 2. But at least in what we've been doing in the classroom, the way that we've been thinking about this framework has been really informative in being able to, for instance, make tools that help people build better STEM tutors. So I think the answer is yes. We'll want to be doing a lot more.
I think just related to that question and direction you're saying, Nick, I think a lot of these current tools are like really limited by what they built and kind of force us like, oh, I can only make a picture with this. But like the things we want to do are very multimodal. And so I'm kind of curious, is that the direction that the team wants to move to, kind of what people really want to do rather than constrained by the tools or even constrained by what you had to do in a human subjects experiment where we have to make it really constrained to run 2,000 people through it? Is that the direction that we would see in year 2, 3?
I think I'll start off with the fact that, yes, we do want to look at how people create multimodal content, but the focus is also on the process, right? Like if I had like an artist, an expert creating the content, the concept and processes they would use is going to be very different from like an educator or student creating the same type of content with a specific goal. So in years 2 and 3, like one of the things we're also trying to focus on is like the process and the concept that relate to these processes that empowers creators and sort of making multimodal content.
James, I think you're already starting to see some new modalities on the team, writing code, interactive 3D experiences, and stuff like that. Maybe one way to think about it is the technologies that have had, you see first are the technologies where big data is easy to come by. And in some sense, that has allowed us to be extremely lazy. As the world starts to make more interesting content, you don't have those examples. And so the world will probably be coming back towards the methods that we're interested in developing, is my sense.
I'll also add a little bit to that. A lot of what we're doing here is studying human communication, and human communication is naturally multimodal. So, we are thinking a lot about how to bring in different modalities into the study and using that to communicate with the AIs.
I have a question about, again, temporal change. And as our world shifts, when you first submitted this application, the world of AI was very different. Gaming, all the applications, art was very different. You are now pitching for the next 2 years. How does your team approach pivoting and changing based on our changing society and the tools available? How will you guys predict that you might pivot in 6 months, in a year?
So,
You should take it. You can take it.
okay, good. I think you're asking a great question. The world in general, especially around AI and AI tools, is moving incredibly fast. And I find it, myself, very hard to predict where the world will go. But one of the things that we are seeing is that for specific tasks, AI only gets you part of the way there. And I think that will continue to happen until we develop more tools using the kinds of methodologies we talked about today. And so I have some confidence that there's a lot more to do in these spaces. But we're very sensitive. We're watching what the world is doing, and we're bringing in those ideas wherever we notice they might, might be necessary for the process. We've made some changes to the original proposal in reaction to what we've seen in the world around us. So there's a move right now towards agentic AI systems. We've also started moving in that direction. The work with Roblox is in that direction pretty firmly, and that's really in line with where things are headed in a number of places around the world.
And if I may also jump in here, this is a callback to some of Kayvon's comments about new courses and also new ways that we've updated our courses to reflect changing reality, right? All of us up here are educators, and we take education seriously, and a few of us study education. And really, we're really serious about taking the discoveries we make and the tools that we build and thinking about how do we build educational programs to equip people, creators, students, learners, wherever they are, to be able to interact with these tools effectively and express their opinionated choices effectively. So I also wanted to highlight that.
Yeah, maybe I can say a little bit more of this from the education side. I mean, I think this is actually a it's a really important drum to beat. Like the fact that things are changing so rapidly, and we're in a very unstable situation where learners are rightfully so questioning what the value is of certain things, and we are as educators questioning what are the right things to teach, what are the right ways to teach it. In a backdrop of technology changing so rapidly. And I think that part of this intellectual work for me is about this exercise of okay, well, what do learners need to get in learning about the creative process, right? And that might change in specifics as technology changes, but fundamentally that's a driving question that I think is motivating all of us in some way.
That's all the time. Oh, sorry.
Just one
Yes,
last sentence is, in some sense, as Manish said, it was a lot has been changed, it's hard to predict. Sometimes I also feel like it's actually easy to predict because compared with what we submitted last year, we know that vision language models are going to get better because there's so much data, and the image generation is going to get better. So that's what we have seen with all the VO3 and all these vision language generation models. But at the same time, language, there's only that much a language can do, and that part hasn't changed. And where you have to do all these nuanced, manipulation and control, I feel like that hasn't been addressed, and that's exactly what we predicted, in some sense in our proposal last year. And I feel like the fact that these tools are getting better actually really highlight the importance when we move to these more complicated domains where we actually have less data compared with just a mass amount of language and video data from the web.
Thank you so much. Let's give them another round of applause.